Ingrid Domenik Meisenger'i davet edeceğiz. Pasif ev düzeyi için enerji etkinliğini
who will be talking about the energy efficient renovation buildings other than residence for passive house level. Yes, please.
Again, I will mention one point to Robert's presentation. My renovation project of the multi-story building was a renovation outside with an outside insulation system. His example was on the inner side. To renovate on the inner side, you have to think over more details, more physics, and because I was asked before, in the multi-story block in Linz, we had the situation that the borderline was on the outside of the exterior wall, and then there was the public space. And in Linz, normally it is allowed maybe to insulate 10 centimeters. It is allowed from the government that you can do it. But when we ask for 30 centimeters, at first they didn't know what they should do, if they can allow it or not. And then there was another point. The insulation was not the most problematic point. Problematic point was that the windows were on the outside of the wall. If the windows had been on the inside of the wall, the warming space would not be enlarged. It would be no great problem. But we had the windows, they are on the outside of the wall. We had 30 centimeter insulation. Therefore, we enlarged the whole building. And at first, nobody knows if it is possible or not. So then we had many discussions with the government of Linz, and they told the social housing organization it is allowed, but you have to pay some taxes. Yeah? You have to pay for it. It is called like an air tax. Also for the balconies, they are on the public ground. They had to pay some taxes, and after it, they decided to buy these 30 centimeters from the government. They can make it there, and that it is the ground of the social housing organization. And you can see this is also in our country is and was a problem if the borderline is exact on the outside of the exterior wall. So, but now I will present another project to show that it is not only possible with maybe schools or kindergartens or living spaces. Also with a supermarket, it is possible to bring down the energy demand. And why should we do this? When we think over a residential building or a commercial building, there are 2 points to consider. When we plan a residential building, we think over energy saving at the first point, and on the second point about energy efficiency. And with commercial buildings, we start with the energy efficiency and then the energy saving. So what's the difference? The energy saving, we have heard much about it now. We can insulate the houses. We can use better windows. There we can bring down the energy demand. But in the commercial building, you have sometimes internal gains, and you have some machines, and therefore the energy efficiency is on the first point to think over them. I will come back to it. Energy efficiency and energy saving is not the same, we heard, but at the end it is the same result. And the same result, our aim is the less energy consumption. The energy efficiency, it can be increased primarily throughout efficient technology. But at first, efficient technology alone will not help. Energy which is not used is the best form of energy saving. looked up for a climate chart from Linz and from Istanbul to see what is the difference. The main difference, of course, is the water temperature, because we have no sea. So, but when you see maybe the average day temperature here in Linz, it is between 20 and 25 in July, August, and in Istanbul it is much higher. But also in this area we have to cool down. We have to cool down our buildings if they are not of a good thermic envelope. And difference is also the blue line. These are the rainy days. They are in Istanbul, they are lower than in Austria. Here in winter, where it is, in winter the average day temperature is about +5 degrees in Upper Austria. To come back to one slide of Robert, here we have heard about it. This is good insulated, therefore you cannot see it in the thermography, and this is the active heating system. You can see it. Why? I will tell you it, because insulation also keeps cool. And this we need for a food market. In a food market there is not a problem how to heat it. Yeah? The heating demand is very high for the old buildings, but you have many internal gains, but the most of them they didn't use it. The higher problem is how to cool it. So here you can see the existing building, the old stack. This is a project where we renovated, we reconstructed, and we made a new construction. Here you can see also an old picture, and this is the area of it. This is the whole building. This was the depot in former times for coal and for wood. They sold coal and wood for the heating for others. And this area is the food market. This is the entrance on the north side, and this is the area of where they sailed, and this is the area of the refrigerators and the depot. The main entrance on the north, it was necessary to renovate. The owner of the building is not a part of a big company, is really the owner. He has investigated into this building, and he also has to pay the heating costs. In some cases there is the person who works in this supermarket is not the owner of this building. He's only a part of the company. The big company investigates, and he has to pay the heating costs. But in this case, he was the owner, and therefore he said, I want to bring down my heating and the cooling demand. I investigate a little bit more for a better thermal envelope, that in future I have less to pay. So he wanted to, because it was not very nice to watch it from the architecture, it was necessary to renovate. He had not enough space, and he had a heating system with oil with about 67 kilowatt. And they didn't use the waste from the frozen cells. And the cooling, they had no cooling system for summer. Yeah? It was not a great problem because they had not very large windows, only very small, but it was warmer than normal inside this building. So what we thought, what we do at first, this was very old. We couldn't use it. Yeah? Therefore, we broke it down. This was the old depot for the coal, for the wood. Nobody needed it anymore. It had a very bad structure, and this was also of a bad structure, therefore we also decided to cut it. We cut this building like to cut it with a knife. It was very interesting, and here you can see it also. Here this we broke down, and on this place we changed the market. At first this was the sales area. We make the depot in this area, and to the south we make the new market because also of the parking place. We had not enough space on the north side. Here is a vertical section of this building, the new one, the existing one, and also here the thermal envelope. We worked with in the roof with a wooden timber construction, and on it prefabricated wall units, inside OSP plate, then 30 centimeters insulation, and then the rest of it. Here is the existing building, the existing roof. Also this area we put on 30 centimeters of insulation, and the outside walls, the existing, with 22 centimeters, and the new walls were of reinforced concrete and additional 22 centimeters glass wool. The facade, the very big glass facade, we thought over. We would like to have a U-value of 0.8, but in this time it was a little bit too expensive, and we decided to take the 1.2 over the whole facade. The glass is better. The problem are the vertically and horizontally bars. Here are some pictures of the construction phase. Here you can see the wooden timber construction, the prefabricated wall elements, and here the insulation. On it there is then a back ventilated Eternit facade, and here the glass facade, and you can see the roof to shade it a little bit. And on the outside then we used a shading system. Pictures from the finished. So, and now to the cooling and the heating system. This is not right, it's only a symbol, but we had a ground well near this supermarket, a groundwater, and we used this water. We use this water for the industrial floor heating. We cool the industrial floor with this water. The water has about 16 degrees during the whole year, and we pump this water from this well, and it comes to a heat exchanger, and it cools down the heating water from the ground. It cools it down that we can cool with this system the whole supermarket and the neighbor rooms. The groundwater is used and is then brought back to the well again, and it is warmed up 3 to 4 degrees. And with this system and the system of the shaded facade, we can cool the whole supermarket. We only use the energy for the pumps to bring it up. Here is the picture. We have a central system who controls everything, the cooling system and the heating system. And we'll go to the next one. Okay. No, sorry. Here you can see additional. We use the energy for the refrigerators also, and 80% of this heating, of this waste energy of the refrigerators we can use, and the rest, the 20% of which we need to heat the supermarket in winter, comes from a heating pump with deep wells. So you can see it again, 80% of the necessary heating is taken from the fridge system, and the remaining is taken from the heat pump. Additionally, we decided to make two rotary drilling with a drill diameter of about 12 centimeters, and we need a depth of 100 meter, two of them, for the additional heating demand in winter. So, the heating costs. Before the renovation, they had heating costs about 5,500 euro per year for the oil. After it, we bring it down to 1,094 for heating and for cooling. To compare, in a market with 600 square meters, you can save about 6,000 euro per annum. And also with this system, the refrigerators, they have less CO2 emission, and therefore you can bring down also the CO2 emission of this system. Here you can see the characteristics. We had a heating demand of the old building of about 100, and after the renovations 42. This seems a little bit seems higher than in the other examples. In this case, we have very big air to heat. Therefore, the 52 part. When we come down to the heating and cooling costs, I said we have heating costs on. This is only for the sales area, the 712 for the heating pump. We have this heating costs for the sales area. For the sales area, we have heating costs for 1.93 euro per square meters. Especially, we have this heating demand because of this special system where we can get the warm bag for the refrigerators. When we start to make our plannings, we should think over some points. And here I have a design strategy. On the basement is the step 1, to think over how to position your building, how it is on the landscape. You can minimize the building area to minimize the heating costs. At the point step 2, you can select a balanced ventilation system with a heat exchanger, not a normal ventilation system. Step 3, consider the possibility of controls for timer, sensor, the shading system, the light system. Then on step 3, here in this area, consider of the possibility of installing energy efficient equipment and lights. This is very important for a supermarket. They have much lights. And then at last, and not before, the most of the owners start to think over what heating system I should use, and then they start to think over about the thermal envelope. First we should think about the step 1 to 4, and then finally, and really finally, we shall think over which heating system we really need in our building. So, we saw it before the slide. We used before the oil. The owner knows, we know, we have no future with this system, and so business as usual is not possible. We think over how we can work in future, what are our possibilities, and the cheapest energy is always this energy which we are not use. And therefore, thank you very much.
Çok teşekkür ediyoruz ve böylelikle bugünün konuşmalarını da
We have finished all